Hello there, I'm Sean Greasley and welcome to our brand new DirectX version 9 tutorials. In this tutorial I will be showing you how to set up the DirectX environment and linking it with the C++ environment. Okay, so what you do first is launch C++ or any similar package which compiles C++ code. The recommended platform to use is the Microsoft version, as I'll be going through this during the tutorials, and this tutorial will apply to the Microsoft version as program packages such as dev C++ may be set up slightly different. So once you've got C++ loaded, then go to Microsoft.com, then the download section. Find something called the DirectX 9.0 System Development Kit Update for summer 2004. This is the complete system development kit for DirectX 9, which creates compliant applications, as you can see, in C, C++, and C#. The optional download is to update this for the October 2004 version, but it's not absolutely necessary. So once you've downloaded this package here, it's just over 200 megabytes. You may need to reset your computer. Launch C++ and open this software program here called the blank direct 3D application, which is for downloadable on the website. So once you have this open and you have the screen in front of you, the same as me, go into Tools, then Options. We're now linking DirectX to the C++ environment. So click the Directories tab at the top, click the Include Files here. You then need to browse for your DirectX Include folder, which mine is located in C, Program Files, and Microsoft DirectX 9 and Include folder. Once you've double clicked that, you can press OK, and as you can see, I've already got one here, but for the example I'll show you how to do it. Once you have done this, you use the up arrow to move this to the top of the list, and as you can see, you can move it down and up, but make sure it's to the top of that list. Once you've done the include folder, go to library files and add the lib folder like so, using the same similar process. So once you've done that, press OK. Then go into project settings and the link tab at the top, and make sure these two files are prefixed before all these library files here. So before the kernel 32-bit file here, make sure these two files are typed here. So direct3d extensions version 9 dt.lib and your DirectX 3d 9.lib here. So once they've been put there, separate each file by a space and press OK, and I think you're now ready to go. So let's launch the application. As you can see, not much is happening at the moment. We've just got a blue background on a, I think it's about 300 by 300 pixel window and a little title bar here. So that's all this application is doing at the moment, but the coding involved is an awful lot just to make a window appear, as you can see. So let's have a look how this is working. Right, as with most C++ programmer applications, we need to include some preprocessor arguments, one being windows.h. This is the Windows library, and it gives you access to the cross-off buttons, as you can see up here, minimize buttons, the other button there, like so, and all sorts like the title bar and title colors, and that's what the windows.h preprocessor file does. There we go. The next preprocessor file to include is the DirectX 3D extensions 9.h. This is the library file for all the DirectX functions you're going to use within your program. So these two files are vital. Without any of them, it will not work. So once you've done this, we now initialize some global variables. I'll just briefly go through this so you can get the familiar scope of the project, like so. So, global variables, there's one called LP Direct 3D version 9. It sets a global variable, which is a pointer, Direct 3D, to null, which is used to create the Direct 3D device. And this is the rendering device, as you can see, version 9, which is a global G pointer. So this is what's called the Hungarian notation. It's named after a famous Hungarian programmer which used to, and maybe still does, I'm not quite sure, programs for Microsoft. And he come up with a notation for anything global. It has a G then an underscore. If it's a pointer, it has a P before the file. It helps you know which variables do what and where they come from, for example. So initialize these to null, as we're just doing a blank application. We then look at the hResult object, if you like, here, which is setting up the Direct 3D, and the parameter here is the window identifier. Each window within your Windows environment, for example, C++, I've got this open now, it may have a window identifier as 3. We want to make sure that when we are rendering shapes, objects, games or whatever, that we want to draw within our specified window. We don't want to draw in this window when we launch our application, for example. So in order to access the current window handle, we use something called HWND, which is like the window handle for the current project you're compiling. So that sets up that. Then the next piece here, we're saying if null is equal to the global pointer of Direct 3D equals Direct 3D crate 9. This is the Direct 3D version here, and return eFail. Now what this does, it links your application to the Direct 3D object to use the graphics. If this doesn't work, then you'll get a fail error message and it won't load. This statement is one of the most crucial within the application. Without this, then your program will almost certainly be doomed to failure. So, moving on, set up this structure used to create the D3D device. This sets up a structure which is called Direct 3D, and I can't quite remember, I think it's presentation package, something like that, but it creates a new variable, if you'd like. I'm not sure if it's certain syntax, but it's based upon the Direct 3D present parameters. So what you're doing first is zero memory. We want to kind of wipe the memory area we're using to create our application. We don't want to overwrite any memory in usage, for example, otherwise we may get memory errors. You may have come across this before. We want to set the windowed to true. If it's not windowed, then obviously it won't be windowed. It's pretty self-explanatory here. Then the Direct 3D presentation parameters swap effect. So we're discarding the swap effect, and Direct 3D presentation parameters backbuffer format is the unknown. We don't really wish to know about this. And then we're enabling auto depth sample to true and the stencil format to 16-bit here. We can change that to 32 if we'd like. What this does here, those two there, I'm not sure if you're familiar with this, but the way monitors work, how it renders a screen, watch my mouse cursor for example, it goes across like this. Say if your monitor is 60 Hertz, then it will do this 60 times a second. What it does, it goes across your screen like this, and when it gets to the bottom corner, it goes back and starts again, draws the next picture. It does this 60 times a second. Nowadays, you know, processors, we've got this 64 bits and whatever such out now. It can do this far many times than 60 times a second. So what it is, our program, DirectX for example, can generate things far more than 60 times a second if it's 60 Hertz, for example. Then back up. So what this does here, this swap effect, it kind of bypasses this procedure. Because we're doing this 60 times a second, the refresh rate of our monitor, and our program's generating such information far faster than this, we're using the swap effect as discard so that we don't get half generated images. Because what might happen if this wasn't the case, we may have a half generated triangle or a half generated shape or whatever. But what this does, it's preventing us from this problem of slow refresh rate and fast CPU, RAM, etc. So that's what the swap effect syntax does here. The enable auto stencil, that's just a stencil on the screen and we're telling it to draw within this stencil, only display this information, so that's pretty self-explanatory. Once we've actually specified all our information into the Direct 3D presentation parameter, we then want to create this. So we have all our information here. We now want to create this device. As you can see, if failed global pointer Direct 3D, it creates this device here. What this arrow here does, it's basically a pointer which is globally referenced outside of the application, if you'd like it. It's the same as saying that because we need brackets here, because the asterisk has a more higher precedence than the period character here. So we do need parenthesis around the global pointer here, but that it's exactly the same as that. So that's why this is used. So once we've created our device here, as you can see, we then want to turn on the Zbuffer. What a Zbuffer is, it's if you generate an image in DirectX, what the computer does, it's just generating what you can actually see, what your eyes can see. With the Zbuffer, it actually generates things behind objects. For example, if you may have heard of a game called Doom, for example, if you go around a corner you may see an enemy there or something. If the Zbuffer wasn't on, then this enemy will not be generated, just the wall in front of it. If we turn on the Zbuffer, it's generating the enemy behind the wall, and it's also generating the wall. Even though we cannot see the enemy and the wall has focus, the Zbuffer allows us to do this. So we're setting our global pointer device here to the set render state Zenable true. If it's false, then we're turning off the Zbuffer. So return OK. That's how to set up our Direct 3D. We're not doing this in any order, but if we just look at this, this cleanup procedure here, it basically releases all the devices we've used in our program. So for example, if we didn't have this procedure here, then when you cross your program off, it's not releasing all the devices, and you may notice a serious amount of lag once your application is closed, because your computer system is still actually using these because it hasn't released them. So this is what this procedure does here. As you can see, release all the resources used by this program. Releasing is valid, have a valid pointer. If not, the program will crash at this point. Try deleting that and running it and crossing it off. You'll notice you will have to Control Delete really quickly and try to exit this as fast as possible. So it's fun to play around with, but do be careful that you haven't got any important work open. Now the next procedure is called render. This, as it says here in the comment, render the frame to the back buffer. What it does, it actually sets up and draws all the things within our application. As we haven't got any shapes or anything configured yet, obviously this procedure is very short. what we're doing here, we're creating a D word, which is a data type of 32 bits. A word is 16 bits, for example. You may have come across these two before. So D word, 32-bit type specifier, holding the background color of the window, which is a hex value of 0x00080, which is kind of like a dark blue. I think I best go over hex in my next tutorial. If we just look at this, take my word for this, this is blue. We then want to clear the back buffer and the Zbuffer. Before, we don't want to really draw over what we've done, we want to clear this, then redraw into a blank kind of application. So we do this with setting the device clear, and here's the properties here. Most of this is jargon, you may not need to know it unless you're really making advanced and superior applications, but I'll give you a quick definition. It's clearing using these parameters here, setting the background color, and we've got a couple of identifiers here you don't necessarily need to know about. Once you've set the background color to this variable, cleared it and re-established the background color here, we're beginning to render the scene. If we've succeeded the rendering of the begin scene, that means it's allowing us to draw. It's putting the, if you'd like, state on hold while we're drawing all our application and whatever's in our frame. Then we put all our drawing information here. This is where we insert our polygons, triangles, for example. Once we've done this, we give the state back to the global pointer direct3D device. That means we're giving control back to the device. Because what we're doing here, we're taking control from this device, so the device can't touch it while we're generating our polygons, for example. Once we've generated all our polygons here, we're giving control back to the device. So we don't want that to mess with it while we're doing our work. Ours is important, so we want to do ours, then pass control back to the device here. So once you've generated all your triangles, present the back buffer to the display. So we're just displaying whatever's stored in the back buffer, which we have defined somewhere up here, in here, yes. So once we've now rendered the scene as such, the next procedure here is the Windows message handling function. This procedure and the one below, WinMain, you will find these two in every single Windows application out there. Office, C++ itself, anything that runs under Windows, you will have these two procedures. If you ever tried to create a blank application within C++, you will notice it auto-generates these for you. You don't need to know them. You don't need to know them off by heart. It will create these. What this one does, I'll result WinMain API, and it's a procedure called message_proc. It takes parameters of the window handler, so we can draw into our window. The message, what Windows operates is kind of like a message queue. I'll come on to that when I explain the WinMain function, I think. But it takes parameter of message, a wparam of wparam, and alparam as alparam. So what this does, each message that your program receives, we're performing switch statements. You all know what a switch statement is. It's really preferred that you do go through the C++ tutorials before attempting the DirectX one. Upon the case destroy, so when the user crosses the application off, we want to call the cleanup procedure, which releases all our devices. Then post a quit message and return 0. So we're telling our application we want to quit now and release all the devices. So then out of this we return the window parameter message, as you can see up here. So that's the message proc. So what this procedure is, it's the handling window for user input. For example, when we pressed the well-known first-person shooter keys, WASD I believe, we can insert a case here. For example, case WM Windows messaging, that stands for, and character. And this is the case that will allow you access to keyboard characters. So as you can see, they're all prefixed with WM for Windows message, then each function or variable if you'd like here. All the possible ones are available on Microsoft.com in the reference pack, so please do look there and experiment with whatever you find. The next and last procedure within our sample program is the WinMain procedure. As you can see here, it's the application's entry point sort of procedure. Is mostly standard and could be used in most DirectX applications. As you can see, every Windows application does have this WinMain function. If you're really familiar with console applications in C++, it's very similar to the main function, and Java as well. You may have used it in Java, where you have public, static, void main, string, args, and whatever. So this is kind of like the application, if you'd like, for the more visual side of C++. It's WinMain, not the console alternative to main. So what it does, it reference parameters as a H instance, and LP, str, and a type integer here. Not important in all honesty, but you may want to research these, but you won't find them useful for when coding DirectX. The next line, however, is more of importance here. As you can see, we're creating a class. When you create programs within C++, this is more of a Windows thing, not a DirectX thing. What it does, it creates a class, then it has to register this class. You can't have a class without registering it. We need to create this class, register it within Windows, so Windows can recognize this as a program, give it its own window handler, and use this within the Windows environment. It's not that simple, but it's quite easy to get your head around. As you can see, most of this is self-explanatory. We've got a lot of null values because we're using a blank application. This is the title of our blank application, so we could say blank app from Grizzly.com, anything you'd like in there. Another null value. If you'd really like to learn more about more Windows functions, please refer to the Microsoft.com dictionaries, and I'm sure they'll tell you more. So once we've created our WC object here of type WND class X, we now need to register the address of this here. Ampersand before that is the address of this, if you've read through the pointers tutorial. So we're registering this class here. Once we've registered the class, we now want to create the application window. As you can see, we're creating the window identifier as a HWND object. We're creating the window of type blank. Obviously we've changed that here, so we need to change that here, or we can just put this back as blank. So what it does, it creates a class as what you put in here, blank for example. And obviously if you change that, you need to change this. Do not leave discrepancies, otherwise it's not going to work. But once we've done that, we can then change anything here, title bar text, overlap window, you can change that to anything you like. This is the left position, yes, left position, the top position, so 100 pixels in, 100 pixels on the top, of 300 pixels wide, say 500 for example, and the height there, so 5 by 2. We then want to call the get desktop window procedure here, and other functions here that aren't necessarily important. Once we've created our window, so we've registered it, we've created the window, and now we want to initialize the Direct 3D at last. So if we have succeeded the setup Direct 3D, passing our window identifier, which calls up this function as described before. So if this is succeeded, then we want to show the window, so pull the show window procedure here. It needs two parameters, our window identifier and the we're calling a show default function here. We then want to update the window using our identifier here, Now enter the infamous message loop. So we're creating message as a class of message. We're clearing the memory, zero memory, as we described briefly before. And here's the infamous message loop. All Windows applications are made up of a message loop. When you type keys in the keyboard, this loop catches them on one of its billion loops as it runs through. That's what all programs are. It's just one big loop. When you press a key, it picks this up on one of its trips around the track, if you'd like, and then calls the function message proc. If the message is for our application, we perform the switch statement on the message. If it's something of relevance, then we'll perform that there. There's our while loop. So message.message. If it's not equal to quit, then carry on with the loop. If it is equal to quit, then obviously quit our application. So while in our loop, we're peeking at the message. These are done. It could be a press key. For example, if we press the key H, we've got key press, key down, key up. So that's 3 events per key. And if we're peeking at the one we want, obviously we've only got one in this sample application, which is WM destroy. So if it's going to do anything other than that, it's not going to be recognized. So when the user inputs data into this, it takes the address of